Good morning, my friends and followers. I am Edward Washroom, the tutor in Edwards Academy. This morning, I want us to look at the procedures and interpretation of two-stage least squares. Two-stage least squares is an advanced ordinary least square estimation, and two-stage least square requires the researcher or the statistician or the econometrician to actually introduce instrumental variables into the estimation to make it more robust. But the fundamental basis is that two-stage least square is a bigger or higher dimension of ordinary least square estimation, and ordinary least square estimation can only be done when the variables are stationary at level, and when time series data are stationary at level. It requires this data, or it implies that those data are mean reverting. If those data has mean reverting characteristics, it means that they actually have a particular trend that they follow, and it is on that basis that one can actually estimate the ordinary least square OLX. But the issue remains that the OLX has too many characteristics and too many factors or too many constraints. In many cases, the ordinary least square estimation actually produce a spurious regression. A regression is classified as spurious regression when such a regression has an over bloated characteristics, or if the coefficients are not statistically significant, or if the W-Watson statistics is below or above the accepted region. So if the arrow square or the arrow square adjusted is also lower or higher than the accepted region, we can also say or indicate the presence of spuriosity in the regression. But this morning we want to adopt a study approach by looking at the impact of bilateral exchange rates on economic growth in Nigeria for the period which spans 1987 to 1981 rather to 2016. To have that done, we have our data already transferred or loaded into an eView worksheet or work file, and the next thing to be done is to proceed with the estimation. Like I said before, what I'm going to be doing this morning is to estimate an OLX and also estimate two-step least square. Then I will now compare the results of OLX and that of two-step least square to enable us know which is better than the other. So let's begin. The first thing to do is to go to quick. We have a quick icon here. If you click on this quick, there will be drop down this way. You click on the estimate equation, then this equation estimation box will come up. The next thing to do is to input your variables. What we have here, we have log of PCI, that is per capita income, bracket closed with a followed by a constant. Then we have the log of GBTNIG, Great Britain's pounds, exchange rates to naira. We also have the log of USD NIG, that is the log of US dollar exchange rates to Nigeria, NIG. Then we have the log of yen, Japanese yen exchange rates to naira, NIG. Just follow step by step. We now have this tray. I may decide to put oil price as a control or moderating variable in the equation. Okay, the log of oil price. I may decide to have this. Okay, this is an ordinary OLX equation I actually wanted us to look at. I want us to look at this. I have omitted one. Let me introduce again the log of Swiss France currency exchange rate to naira, the log of Swiss francs NIG. Okay, we have these variables. So Under the method, you leave it at least square. I haven't specified your equations with a constant. You visualize your equation, ensure that there is no error in your typing, and once that is done, the next thing to do is to click the OK button. If you hit the OK button, you will get a result like this. This is a typical OLX result. If you look at this result critically, we have variables, we have coefficient, we have standard error, we have the statistics, we have their probability values, we have R square 92, we have adjusted 90, we have the Watson statistics 84. So I will save this result as equation 1. I will save this result as equation 1, equation 01. Okay, I will go back to estimation box. I will change the estimation method. Go to estimation box, change the estimation method to two-stage least square. I'll hit it. Once I hit that, I will now be exposed to this. This is the new estimation box now. I want to estimate the two-stage least square. The next thing to be done is to, under the instrumental list box, you now have to specify the instrumental variable. But the rule of thumb is that the instrumental variables must be variables related to the explanatory variables. So in this context, we actually will be using the lag values of the explanatory variables as our dependent variable. So given that, I will now have to input in here the past realizations, the past values of the explanatory variable as my control variable. We have GBTN AG lag 1 as my control variable 1. I will now put the second control variable. I will put the lag value of USD as my second control variable. The third one will be the lag value of Japanese yen. The next one will be the lag value of Swiss francs exchange rate to naira. Then the last one will be the lag value of oil price. I think that is the last instrumental variable. Ensure that the parentheses are the same. Look at the parentheses. We have 2 here, 2 here, and if everything seems correct without changing any other thing, remember that the method must be changed to two-stage least square. If you hit the OK button, you will now be exposed to another result that looks like this. So with this result now, I will save this result again as equation 2. I will save this as equation 2. Okay, equation 2 is my equation 2. Okay, the next thing to be done now is to compare the OLX with the two-stage least square results. So let's do the comparison. We have the two-stage least square results as equation 2. This is equation 1. We have to open equation 2. Where is the results? Wow. Where is the results? Wow. Equation 2 has disappeared. There's an error. Okay, let me re-estimate equation 2 again. Let me re-estimate equation. Okay, this equation 2. Let me re-estimate equation 2 again. Okay, this equation 2 rather. This is equation 2. We have equation 2. Let me open equation 1. This equation 1. Wow, we have equation 2. Equation 2. Okay, this is equation 2. It's like we can't find equation 1 again. So let me re-estimate equation 1. Let me re-estimate equation 1. I think I have to do that swiftly. Let me re-estimate equation 1. Re-estimating equation 1 will just take 2 minutes. I hope to come back in 2 minutes. So equation 1 will be re-estimated, and this is equation 1. Okay, this is the OLX equation, and this is the dynamic model, or what they call the two-stage least square equation. So if you look at these two analysis, you observe that in the first equation we have in the first equation we have the variables. We have the variables here. We also have the variables here. These are the variables. We have the coefficients. We have the standard error. We have the t-statistics and the probability values. And the rule of thumb is that if the t-statistics is more than 2 or 2 and above, it connotes that there will be statistically significant association, or if the p-values are less than 5%. And if you look at this t-statistics, majority of the t-statistics are above 2, and majority of the, in fact, all of the almost all of the p-values are all above are all less than 5%. That means that majority of the parameters here are statistically significant. If you look at the arrow square adjusted and arrow square, you observe that the arrow square is actually higher. The arrow square is 92%, and the arrow square adjusted is 90%. And the double Watson statistics here, if you look at the double Watson statistics, is less than the accepted region. So basically, this result, though the parameters seems good, but they are signs too. The signs of these parameters actually speaks volume. Although it is expected that the bilateral exchange rate will have negative impact on economic growth. And if you look at the signs of GBP, USD, Japanese yen, they all have, or they all conform to economic a priori. But the issue remains that the double Watson statistics shows an evidence of first order autocorrelation, and the arrow square adjusted is overbloated. So given these two issues, we need to go to the second estimation, which is two-stage least square. If you come to this other estimation, the two-stage least square, you observe that the parameter of interest, though majority of them are not statistically significant, virtually all the parameters are not statistically significant. The arrow square adjusted, to me, is okay. Double Watson statistics of 1.15 is also lower than what is expected. So basically, in this estimation, if I'm to choose, the OLX is better than the two-stage least square. Why? Because the parameters of interest in the OLX estimate were all statistically significant compared to what happened in the two-stage least square. But this is how you estimate a simultaneous equation model, because the two-stage least square is unlike, in fact, it's an estimation for simultaneous equation in econometrics. So if you are doing a study that requires you to run simultaneous equation, please try to use two-stage least square, but always compare the result of the two-stage least square with ordinary OLX to enable you determine which is the best to be used. Please try to always like our videos and subscribe to our channels. Thank you for listening. God bless you.